Helen, should I just go ahead and start? I'll go into that. Okay. So let me, hello everyone. I'll just go ahead and start the screen share and show up the slides. Good afternoon, everyone. I am Arun Mishra. I'm the David Eccles Professor of Marketing at the University of Utah. And I'm going to be talking about how you can increase access to justice through using accurate and fair algorithms. So something about algorithmic development and deployment. And I would like to thank the Office of Legal Services Innovation, Lucy, John, and everyone, and especially Helen, for making this happen, and also to thank you to Justice Lab for sponsoring this event. Now, so we see algorithms everywhere, right? Algorithms influence many of our decisions. And also before I start, please feel free to stop me if you have any questions. I'm going to sort of give a broad overview. Feel free to stop me and we can go into deeper discussions at any point. I may not be able to see the chat all the time, but feel free to just raise a hand or just ask me a question. So we see algorithms in many important decisions in life, be it like medical diagnosis or in many kinds of recommendations that we receive from algorithms. For instance, algorithms help us figure out, what kind of news we want to read in news feeds and social media, which movie we want to see, for instance, Netflix providing different types of recommendations, which restaurants to eat in probably, even which life partner might be the most appropriate for us. In driving, we are seeing algorithms in many aspects ranging from, just Google Maps telling us which is the best street path to take, or in self-driving cars. In business, we see a lot of influence of algorithms, be it in scanning resumes for hiring decisions, college admissions, figuring out whom should be given a loan or not, fraud detection algorithms, and of course, in stock market predictions, where many trades can happen in literally microseconds, we see the presence of algorithms. This is more in their predictive ability, but in their more generative ability, we see algorithms in the creative pursuits like writing very persuasive essays, composing new pieces of music and poetry, or coming up with beautiful paintings. So yes, algorithms affect different aspects of our everyday life. Now, if you look into the presence of algorithms in the legal system, we see that algorithms might be helping a lot of end users, for instance, in filling out forms, helping them file forms online. They have legal experts, do document review, trying to figure out which might be a relevant piece of information, which might be an irrelevant piece of information, so that instead of legal experts, lawyers, and judges having to wade through a lot of information, a lot of documents, algorithms are helping them become a lot more efficient, saving them time, and going through thousands or even millions of documents that might be related to a case. They also help in some form of legal evidence searching. For instance, if it's corporate law or there's a case and they are searching for a specific word, then in legal diagnosis, we do see the presence of algorithms where evidence can be searched for instance, going through hundreds of emails and searching for a specific word or words that might help find evidence for or against a case. Chatbots are also something we are seeing quite a bit, which is helping end users like defendants or petitioners navigate the legal system. In many self-help centers that are being created using chatbots, we see that through simple question answer process, algorithms are sort of able to guide people through the system, helping them fill out forms, filing forms, helping them answer simple legal questions, getting them to become more informed about the legal process. Algorithms are also being used in more of the prediction tasks, be it like predictive policing. Sometimes trying to, so like crime has features, fingerprints, right? And then algorithms are able to figure out those fingerprints to find out whether this, looking at a crime and finding out what might be the features that are similar, maybe to find out who might be the person that's perpetuating the crime. Another form of predictive policing is to find out whether there is some kind of a pattern across some crimes that might be happening even across different locations. Facial recognition algorithms are also being used for predictive policing, just to find out if there might be instances of unrest in some place, whether there is a certain pattern, whether there might be some people there who might give a clue that some events might unfold. I will be using a sentencing algorithm as an example in later slides. Essentially, sentencing is trying to figure out, like in pretrial cases, algorithms are being used to come up with a risk score, right? To figure out whether somebody in a pretrial, a defendant should be allowed out on bail or not. So some of those sentencing predictions are also helping, algorithms are also helping in those kind of sentencing predictions. And the algorithms can be of two different types. Either they can be acting as a decision aid, where they're just gathering a lot of information, saving time, or sometimes we might be seeing them behave in a more autonomous manner, where they are taking more decisions, for instance, like form filling and things like that. So in the legal system, we are starting to see the use of algorithms a bit. Now, if you think about algorithms, they are very efficient. So we need to be able to harness that power of efficiency of algorithms. And if that can make algorithms or more accessible, that can make justice more accessible, access to justice, increasing that by the use of algorithms, that would be a win-win situation for many people. And we are seeing the use of algorithms used to increase such accessibility. For instance, people can go to these easy to use platforms, like online platforms, or some of these being rendered through apps that can help people fill out forms. It can help them cancel unwanted subscription. They can dispute parking fines, ask for refunds, simple tasks, but increasing people's access to justice. Many times people, and many times underprivileged people, they may not have the time because they are working many jobs. They may not have the time to do many of these things in person. And at this point of time, having a more accessible platform, the use of algorithms will really help them have better justice outcomes. For instance, it would help in reducing default judgments and many of these simple things which they might not be able to do before. So it's very important to be able to harness this efficiency and really the power of algorithms to increase access to justice. Now, that is really wonderful. Algorithms can be used for many of these things, but it's also important at this point in time to say that, yes, increase access to justice, but the use of algorithms should not lead to any to discrimination, right? So the important question to ask at this point would be, can algorithms be unfair to some groups? And the answer seems like it shouldn't be. It should not discriminate across groups, because algorithms, by their very nature, are using thousands of pieces of information, right? They have the ability to crunch through a lot of data. So if they are crunching through a lot of data, then they should be very objective. But is that so? Are they always very objective? And instances have been found where that may not always be so, right? And what has been found is in the hiring decision making, not in the legal system, but in a hiring decision system, what was found that sometimes these AI-based hiring systems were discriminating against female candidates, especially for certain types of jobs that might be related to, for instance, software or technical positions. The other place where they found that there might be some discrimination was in facial recognition algorithms. What was happening is that these algorithms, and I'll talk about why this might be happening later, these algorithms were less accurate at identifying darker skinned faces and also faces of women compared to lighter skinned faces and faces of men. So somewhere their output or their predictions were having more errors for certain groups. That means their output was biased for some group versus against some group. But if this is true, that means their predictions were not equitable across across all groups. So there, it makes sense to pause at this time and say, is there something wrong? Might there be, as what's said in algorithmic development, is there some bias that is creeping into the algorithms? To understand that, let me first sort of explain how the algorithmic development process occurs. So if you think about it, in a very simplistic manner, algorithmic development goes through these three simple stages. The algorithm, first of all, learns patterns and rules from existing cases. And this process is known as training the algorithm. So what happens in the training phase is that the algorithm is given some form of data. And this data is based on existing cases. The data, when we say this is also called as training data. The training data at this point is likely to have different types of variables, and we tend to sort of divide those variables up into two parts. We call one set of variables the input variables, and the other variable the output or the predictor variable. Now, input variable, let's take the example of detecting a credit card fraudulent transactions, right? If you want to find out whether a specific transaction using a credit card was fraudulent or not, you train the algorithm to be able to check for some patterns. And the training data in that case would have input variables, something like where the transaction took place, the location of the transaction, the time of the transaction, how much money was involved in that transaction, things like that. Features of the transaction would be the input variable. And the output variable or the label would be whether that transaction was fraudulent or not. So this would be what the training data would look like for the algorithm. Then the algorithm will use a mathematical model and learn associations from those input variables and learn to predict the output variable. So once the mathematical model has been applied, now we need to find out, how well the algorithm has been trained. So we evaluate or test the algorithm on what's known as a test data set. The test data set is predicting and getting the algorithm to predict on new cases, right? And the new cases would be where we give the algorithm only the input variables, where we give the algorithm features of the transaction, right? But we don't tell it whether it was a fraudulent or not a fraudulent transaction. Using what it has learned, these associations, these patterns that it has learned from the training data, then on that new data set, the test data set, the algorithm will come up with predictions. Now, again, we need to be able to test how good the algorithm's predictions are. So usually what happens in the test data set, the developers have information or they have the outcome variables. It's just that they don't show or tell the algorithm what those outcomes are. So this is the actual outcomes are also known as ground truth. So this is the truth against which the predictions of the algorithm can be sort of tested. So once the algorithm comes out with predictions on the new cases, we already have the ground truth, and we sort of compare the algorithmic predictions with the ground truth predictions. And we see how accurate the algorithm is in being able to predict. So in a simple way, this is how the algorithm gets trained, a mathematical model is applied, and then we test and evaluate the accuracy of the algorithm. Any questions till now?
Arul?
Yeah, Lucy.
Is this what you're showing us? Is this an example of sort of machine learning algorithmic development and would it be different for deterministic or rules-based algorithms?
For for any kind of a prediction, Lucy, this would be the pattern that they would follow. So the mathematical model for a deterministic algorithm, that's where it would change, but it would be the same sort of outcome predictions which would be followed for either it's machine learning or if it's deterministic too.
Okay,
if it is making
thanks.
any prediction. Yeah. Okay. So moving on. So if you look at a recidivism prediction system, in this case, let me use that example here. So they have different types of recidivism prediction. Recidivism is basically trying to, pre-trial determining whether a defendant can be released on bail or not. So there is a risk for doing so, and that is what would be the outcome or the prediction that the algorithm is making is what would be the risk of releasing a defendant out on bail pre-trial. So many of the recidivism prediction systems sort of follow the same pattern. What they end up doing is they input several factors, which might be features of the crime or features of mostly features of the defendant, for instance, age, gender, criminal history, and sometimes based on surveys also. This information goes into a mathematical model and output is produced sometimes in the form of a risk score. So 1 would be low risk, 10 would be high risk, right? And this has influence on whether somebody is, the defendant is released on bail or not. So this is essentially finding out the risk of whether some of a defendant reoffending or not. So if you put it back into the algorithmic development framework that sort of I've had, so the training data in this case for the algorithm would be, defendants' features, for instance, age, previous crimes, whether substance abuse. Sometimes it goes from anywhere from 100 to 150 different input features. The outcome in this case, the prediction that we would be looking at would be whether the risk score, the likelihood of a defendant reoffending or not. So once the algorithm has been trained on the training data, we apply a mathematical model. Again, it can be more simpler models like logistic regression, a decision tree, or maybe more black box models, which I'll come to, like a deep neural net. But it'll all be providing some sort of a prediction, predicting the risk score. When we have the algorithm's prediction, again, as in the past, we need to be able to make sure that is this algorithm, what's the accuracy? Is it predicting fine or not? And then again, we will evaluate the predictions of the algorithm on a test data set, where it will predict new recidivism cases where it only sees the input, not the output. Now, in this case, along with prediction accuracy, one more thing, given the new instances that have been raised about whether these algorithms are equitable, whether they are fair, whether they are non-discriminatory across different groups, we can also test for whether these are fair predictions. And research has done that. They have gone back to try and figure out whether these predictions were fair or not. And it was found that if you look at one group of defendants who actually never reoffended, and we look at algorithmic predictions for them, and one of the algorithms that was used for this, what the algorithm did was it ended up predicting a lower chance of reoffending for white defendants, but a higher chance of reoffending for Black defendants. And this would be for some of you familiar with the confusion matrix, this would be very high. It was almost double for a higher chance of reoffending. So this would be a high false positive rate. Now, if we look at the other group of defendants who actually did reoffend, in this case, what the algorithm was predicting was it was predicting a lower chance of not reoffending for Black defendants and a higher chance of not reoffending for white defendants. So again, the predictions of the algorithm were not equitable. And so this gives rise to this question that, maybe there is some bias where the predictions were not equitable. And so it makes sense to figure out where the bias might be coming in from, right? And not just for this recidivism case or recidivism algorithm, But in any situation, when we do find out that the algorithm might not be equitable, it makes sense to try to figure out where the source of the bias is, where the bias might be creeping in. And so what I'm going to do is I'm going to use this, again, simple algorithmic development framework to sort of pinpoint where the bias might be coming in from and how we can come up with ways in which the algorithm can become more fair, more accurate. Because along with accuracy, we need to make sure that it is also not biased. So let's look at when it's learning patterns from existing data cases. So this is the point of training. Some of the times bias might creep in from the training data set. And at this point, we need to keep in mind that the training data is being produced by human beings, right? So it may very well reflect human biases. And when the algorithm learns on the training data set, it is learning lots of opinions and judgments of human beings, but it's also learning human bias. So if you want, this is a golden opportunity where if you're leveraging the efficiency of algorithms, this might be the perfect place to make sure that if we remove the biases that the algorithm might learn, then we can end up making very efficient algorithms, scaling it up, but also making sure that they are very fair and they are less biased and they're not biased at all. So in the training data set, where could the bias come from? So, and the bias was, and again, one more thing to keep in mind is algorithm by itself is not going to bring in any form of bias because of the mathematical model. The bias generally comes from somewhere outside, many times from the training data set. So one way where the training data set is likely to be biased is overrepresentation, right? What happens is when we look at the training data and it has any one group of people overrepresented in it, then the algorithm is going to learn to associate the input features to the outcome using that overrepresented group, right? So when we looked at the facial recognition algorithm and said that it was making a lot more errors for darker skin faces, it was probably because the lighter skin faces were overrepresented in that training data set. So it was not learning enough associations or features for darker skin faces. And that's why it was making more errors in recognizing those faces. Another thing that can happen connected to the recidivism or, when you're sort of making predictions about defendants is sometimes oversampling of any one racial group with some criminal activities results in algorithms having an overrepresentation of that racial group in its training data set. So when it has to make those predictions, it ends up predicting a higher likelihood of that racial group committing a crime just because it has seen more of those that group overrepresented in its training data set. So the solution to this is, of course, making sure that your training data set is well represented of the population, that your algorithm has seen enough samples, right? So that's one way. Another cause of bias in training data set can also come by this fact that what happens, and rightfully so, sometimes what happens is people, developers, try to remove some protected attributes from the training data, like race or gender or any of the protected demographics from them. The one thing they need to keep in mind is that just by removing those demographics, those protected attributes, the algorithm still has the ability to infer those very same protected attributes if some correlated variables or proxy variables still exist in the data set. So sometimes if the algorithm is pretty good at inferring gender or race from correlated variables like income, age, address, zip code level information, education levels, many of those times it's able to infer those protected attributes from those correlated variables. So even sometimes de-anonymizing data set, one has to be very careful that are all types of variables sort of removed from the data set, because if they are not, sometimes the bias can get enhanced, but the bias can remain there because the algorithm has the ability to infer those protected variables from proxy variables or correlated variables. And then, of course, having a less representative sample or a less diverse data sample in the training data set doesn't allow the algorithm to learn different features. The more diverse, the larger the samples that are used to train the algorithm, the better able it would be to, come up with more diverse and representative predictions for all across different groups. If it has seen enough groups, it has seen the features of those groups, and it has seen those outcomes, it is better able to come up with predictions that are more fair and equitable. And this also helps in accuracy, because the bigger the sample, the larger and more diverse the sample, its accuracy is also going to be significantly improved. Now, that's focused on understanding where the sort of bias is going to come in when you're training the algorithm. Now that we know, sort of given enough instances where people have called out that, yes, algorithms do end up showing some form of bias. They may not always be equitable. Focusing on accuracy is important, but focusing on fairness is also equally important. Let's look at whether there might be some solutions that have been used. And there are some solutions to make sure that you develop fair algorithms. And that would be in this, in this stage of evaluation. So there are broadly two ways in which we can develop fair algorithms. One is in trying to come up with technical solutions, and one is using more cultural solutions. So in terms of technical solutions, I'm going to be talking about three different things. The list, this is not an exhaustive list. This is just three features that we can think about when we are trying to develop fair algorithms. So if we go back to this algorithmic development, we can see that you can bring in algorithmic, when we are training the algorithm, we can help it become a more fair algorithm, mathematical models, and also when we are sort of evaluating or testing process, there also we can do something. So the first thing, of course, when we think about accuracy of an algorithm, we have pretty good metrics, right? We have the ground truth, we map the predictions of the algorithm to it, and we see how accurate the algorithm is in its prediction. Is it 100% accurate? Is it 50% accurate? We can find out the accuracy pretty well. So at this point in time, it's also important to come up with good fairness metrics, right? If it's easy to evaluate something, we can improve it. Accuracy is easy to evaluate. We are pretty good at trying to improve accuracy by changing different features, the weighing of the features, all of that thing. Now, the good thing is with many organizations now having this aim of developing fair algorithms, a lot of fairness metrics have been developed, right? Have been put forward. So anywhere from almost up to 20 different fairness metrics have been put forward. One of them that I'm going to be just briefly mentioning is disparate impact, but there are quite a few fairness metrics, and it would depend on the organization which fairness metrics they want to use, because depending on the organizational objectives of what type of fairness they want to achieve, different metrics can be used. So disparate impact very simply just states that, so the proportion of underprivileged who received a favorable prediction, the ratio of that to the proportion of privileged group who received the favorable prediction. Now, ideally, the value should be 1, because if it is a fair algorithm, it is going to be equitable to both those groups. And so the 100% of the time you should have a fair outcome. So that's more of, technically you can evaluate whether your algorithm is fair or not. So that's one way in which you can figure out whether your algorithm is fair. You have a good metric to evaluate it. Anywhere from 80 to 100% is considered okay, but anything less than 80% means your algorithm is not coming out with equitable solutions for everybody. This is another way, and another technical solution that can be implemented is bringing in what's known as human in the loop or expert in the loop. And in legal decision making, that would be bringing in the lawyer in the loop. So if you think about it, many times if you have to give any form of legal advice, you should have the license to practice law, right? And so it makes the most sense to have people who have the legal expertise at different points in how you're developing the algorithm, right? And this is not something new. Human in the loop has been used for many things, specifically for self-driving cars to pretty much figure out, this might be a problem. The car has to drive like this. So in the legal decision making too, the ideal way is to develop fair algorithm is to bring in the lawyer at different stages in which the algorithmic development and deployment is occurring. So starting from the process where you are gathering data to train the algorithm, at that point in time, the expert can figure out, is this a diverse enough data? Is this large enough? Is it representative enough? That can lead to more accurate and fair predictions. The algorithm can then be trained and come up with its predictions. At this point, using the fairness metrics and the accuracy metrics, the algorithm can be evaluated to check for whether it is coming up with fair outcomes, whether it is accurate also. And the organization at that point in time can sort of figure out, am I happy with this level of fairness? Or do I think that it can become more fair or more accurate? Again, the lawyer can come in and they can decide whether it is good enough or not, or does more things need to be done. At this point, again, if they feel that the fairness outcome is not good enough, the expert, in this case, a lawyer, can go back and relabel the data, right? Maybe they can tweak the algorithm in the sense that the mathematical model that's going in, the input data can be reweighed, relabeled in some way so that fairness outcomes can improve, right? The value that you're getting on, let's say, disparate impact improves from an 85 to a 90%. Again, once the data is relabeled by the expert, by the lawyer, it is given back to the algorithm and the algorithm is retrained. And again, it gives out an output. And again, you can test for whether how much is the accuracy or how much is the equity values for the retrained algorithm. And this process can keep going on. And that's why sort of having this expert oversight through this process is good, because you can evaluate the algorithm in a pretty much continuous manner. And norms can change, laws can change, and this process can keep continuing. And then another way, another technical solution that is possible is to have different sort of mathematical models. Whenever we hear about machine learning or artificial intelligence, we sort of hear this word black box models. And they are called black box algorithms because they're using some sort of a complex mathematical model to come up with their predictions. But they are opaque. We don't know what input features and in what weight they are using those input features to generate those final predictions. So if you think about a case for an end user, right, it becomes very challenging to explain to them why their loan application was denied or why an applicant was not hired. If you use black box predictions, it's difficult to explain what were the features that generated that prediction. And that's why this is something for organizations to think about, that what kind of a mathematical model works out better. If you want to have a more explainable and interpretable model, which sort of gives you insights into which features and what weights went into making that actual final prediction, then using something like the white box or the glass box algorithms, or it's also known as explainable AI, the XAI, can be used in that algorithmic development. It may suffer a little bit on prediction, but it would probably be very explainable. And it also helps someone understand, if some features changed, would the prediction change? So that's another way in which you can develop a more fair algorithm because it's more explainable to the end user. And no technical solution can work if there isn't a cultural change too. So cultural change can be in terms of, having this almost like a fairness framework in the organization. So everybody, to the people, from the people who are collecting data, know what type of data needs to be collected, how much data, and how representative or how diverse the data set needs to be collected. And to the people who are developing the algorithm, to the people who are deploying the algorithm, there is this nice cohesion because there's a nice fairness framework that has been communicated to everybody is working in that organization. This again maps on to also being able to reward fairness efforts, um, along with developing really accurate algorithms. If people who develop fair algorithms are rewarded as much, it would lead to a lot more people trying to work towards building these fair algorithms. And then finally, of course, having a diverse workforce allows those expert in the loop that we were talking about be able to bring in a diversity of opinions to check for algorithmic fairness and accuracy at different points in time. So culturally, these solutions are definitely possible across to build these more fair and accurate algorithms. So essentially, to conclude, algorithms are very powerful because they are very efficient. They can go through large amounts of data. And if they can do that, and if they do that in a way that's fair and avoids discrimination, it can really increase access to justice for several people because, like many of these apps and many of these organizations are showing, they are able to get people to navigate the legal system a lot easier, many of them being online, many of them being through apps, but that can really increase access to justice. So it's a great time right now to sort of harness the power of algorithms in a more fair manner to increase access to justice. That's all I have. Questions?
I do have a question.
Yeah.
So this is really interesting. I kind of work in a space where we deal in a lot of technology issues and things like that. But also we've been working in the DEI space recently. And I love seeing the positive opportunities for algorithms to be used in a way that could increase access to justice. But I do wonder about some of the negative uses, and looking at specifically the example you had today with recidivism projections, for example. I wonder how you think about dealing with issues of equity when it comes to not just being able to predict well because you correct for things like, representation issues in the data set, but on the outcomes themselves, like with recidivism, being an accurate predictor in some ways just shows that it's accurately predicting biases that are already built into the system because our outcomes reflect bias. And so I just wonder how you deal with that and how you think about correcting for that or using these algorithms that we know are predicting unfair outcomes. Like, how can you use that sort of algorithm in a positive way if we know that it's accurately predicting what's probably an outcome that reflects some biases itself?
That's a really great question, and this is something that I did not speak about, but it's also known as the accuracy equity trade-off. So sometimes, yes, these algorithms are very accurate because the ground truth that we are sort of comparing their predictions on have these years of past data, historical data against which these algorithms are sort of tested against, evaluated against. They have those biases, and if these algorithms don't predict matching those, then we would say that the algorithm is not accurate. And that's the point in time where two different entities need to sort of play their part. One would be the expert in the loop. They would have to come in and say, look, I am going to give up on so much accuracy, but it is going to become a lot more equitable in the future. I can't change what has happened in the past, but I can change what is going to happen in the future. So I'm going to take a little bit of hit on accuracy, but I would try to make it more equitable. The other, of course, is the organizations themselves, where they would need to say that, fine, many organizations focus on accuracy because that's going to increase their profitability. But in many instances, it's not a question of profitability. So in that case, if they can say that, okay, look, let's use all of these fairness metrics and make sure that on these fairness metrics, the algorithm is doing fine. Yes, again, it's going to take a hit on accuracy, but maybe what I was defining as accurate was something which had a lot of bias in the biases in the past is probably not a good metric. So I think that, so that, like I said, it's not just a technical solution, but it needs to have more of that cultural solutions playing a part. But yeah, it's usually the accuracy equity trade-off.
Thank you.
Any other questions?
I'll ask another one. Oh, somebody, Lucy raised her hand.
You can go, Marie.
Oh, I was just going to say, what are some of your thoughts on what you see as, really practical applications on this? Like at the beginning, you sort of addressed some different areas where it's being used. What are some of the ones you're most excited about?
So definitely, some the ones that really excite me is where it can really increase access to justice kind of issues where the underrepresented, the protected groups, if algorithmic power can be used. So, for instance, in some form of any form of online uses where people who are so busy that they sometimes don't understand that they are facing a legal problem, or they don't have the time to go ahead and address that legal issue. If algorithms can somehow, be it in the form of chatbots, be it in the form of filling out forms or those kind of things, where literally, if they can't go to a place to get justice, if justice can become more accessible to them through many of these algorithmic uses, that is what something that really excites me. I mean, that will hopefully be truly harnessing the power of algorithms.
I just thank you. I really appreciated everything you were talking about today. And, maybe Lucy and Dino and the other people on the task force are going to help us implement it here in Utah.
Dino and Lucy and
Well, I'm no longer on the task force. A rule is going, and Lucy and John and Helen and everyone is going to help you implement it in Utah, and then I'm just going to vote for it.
That's also helping.
Arul, my question was whether there are any sort of external, either governmental or probably not governmental at this stage, but at least not in the US, but nonprofit organizations that provide sort of whether expert assistance on this or certification, particularly on the fairness piece for algorithm or for service providers using not necessarily just in legal, but generally across the board on the equity piece.
That's a great point, Lucy. I think a lot, and I can answer it from academic research point of view. There have been quite a few papers where they are coming up with these different metrics to evaluate fairness. So the fairness metrics. So that is one great way, because just like we have accuracy, which is measured by how good I am at predicting given my past data. If those metrics can be used, that's one way I would say we can use it to move forward. They are getting applied in different places, and I think ideally, if more and more people use those metrics across different data sets, not just in the legal system, like you mentioned, but like let's say self-driving cars or many different ways, providing recommendation systems in businesses, how fair they are. So if we see many of their uses over time and it gets validated, and also going back to what Mario was saying, that if it can help us see that, okay, if I'm using this fairness metrics, my accuracy gets dinged by 2%. Am I okay with that? So yes, we need more of their applications in, let's say, the real world or real use cases too. But I wouldn't know about whether, so the more cases they get used for, I guess that's some form of a public approval, but I don't know about government approvals. Yeah. Any other questions? I was thinking of showing you all a video, but it's it's about how algorithms are now trying to simplify. It's a natural language processing algorithm that's sort of simplifying contracts. I'll try and show it. I'm not sure if it's going to work, but it's worth seeing. It's a generative model which is sort of simplifying contracts. Let me see. Give me one second. I probably need to pull it up. So this is GPT-2 or 3, one of them.
Given any prompt, the API will return a completion, attempting to match any pattern you give it. You can program it for any task by instructing it in English of what you'd like it to do. For example, let's take a typical non-disclosure agreement and distill this content down to something much more understandable for the non-lawyers like myself. First, I'll prompt the API with "my second grader asked me what this passage means," and then I'll include the following section from a standard NDA. I'll hit submit, and the API takes this prompt to summarize this body of text in a simplified form.
So essentially, it sort of simplifies things. And sometimes, for non-lawyers like me, seeing that in a very simple manner and using NLP and, natural language processing or text analysis to explain things in a very simple way, it's very helpful. So we'll see how AI is going to hopefully simplify many things in the future.
Yeah, that was a really interesting example. I feel like I've seen other examples like that, but in the legal research context. Like, I know that Lexis and Thompson and Ross Intelligence have all, put a fair amount of resources toward that end, but I haven't seen it as much in consumer-facing products.
Yeah.
Can I ask you a question about that? So if you think about expert review then of that, if that were the product that was coming out through the algorithm, what would the lawyer's role be as the expert to check on that?
Yeah, and the lawyers do have a very important role there, because if you're simplifying but not simplifying that, it ends up being wrong. So they have a very important role in that, because the natural language processing algorithm is just going to use some pre-trained work in order to do that kind of a translation. But the expert needs to be able to say, look, if I'm going to show it to a client, not a second grader, but to a client, to sort of simplify these things, is it correct? And is it too verbose? Many of those things, right? So they do play a very, very important role. Yeah, experts in the loop are important that way.
I have a I don't know if it's really a question, but a thought or something I'm thinking about related to that. It's, there's the text summarization, which that demonstrates, which is interesting and seems helpful, but it doesn't really provide any guidance in terms of like the judgment, whether signing this contract is a good idea or not for the client. I'm wondering, or I'm thinking like that's another place where expert input could be very valuable.
Yeah, you're right, David. Yeah, and I know Lucy and John can answer that a lot better than a non-lawyer than me.
Yeah, it's a good point. I mean, up until really this point in Utah and across the country, the software was not permitted to do that, not permitted to offer the guidance. And so that's what this opportunity of the sandbox hopes to facilitate.
thank you, everyone. This was, thank you for listening. Thank you for your thoughts and input. And happy holidays.
Thank you so much. This was great.
Thank you, Marie.
Thanks, Arul. Thanks, everybody.